If you are interested in troubleshooting your LAN or WAN issues, or performance, then you will need a Ethernet testing tools such as PacketCheck. The PacketCheck application is designed to take all confusions out of Ethernet and IP testing at all layers, starting from raw Ethernet frames to VLAN, MPLS, IP, and UDP packets. The application transmits and receives Ethernet or IP packets over the network, and includes most all modules necessary to perform Ethernet testing, which includes BERT, throughput, delay, and impairment functions. You can test Ethernet traffic of up to 800 Mbps. Generate full duplex multi-stream traffic on any of the 4 layers with on-demand bandwidth. PacketCheck does not impose any upper limit on the frame size. It supports user-configurable frame size, ranging from 64 bytes to 1514 bytes and even more for jumbo frames. Similarly, flexibility is given to edit any layer MAC, IP, and UDP header parameters. It can generate runtime impairments. Once the testing is completed, you will be able to measure and monitor performance statistics. In this training, we will focus on performing Layer 4 testing between the 2 networks using PacketCheck. Test setup at Layer 3 involves connecting PCs through IP routers or switches. This tests the router's ability to route IP packets correctly at various speeds, and measures the ability of various routers on the path to forward IP packets without dropping and in sequence. Packets are routed between the source and destination PCs based on both the IP address and MAC address. So, both the MAC address and the IP addresses have to be configured for Layer 3 testing. Test setup for Layer 4 is similar to test setup for Layer 3, as UDP is carried on IP. At Layer 4, UDP packets are sent instead of raw IP packets. This verifies the ability of the IP network to sequentially route the UDP packets to the destination. For Layer 4 testing, source and destination UDP ports need to be configured in addition to MAC and IP addresses. PacketCheck can be operated on both normal and loopback mode. In normal mode, PacketCheck allows to generate and receive packets on multiple streams with different set of configurations. Whereas, in loopback mode, packets received from a device is transmitted back to the same device without any modifications in the pattern. Let's learn how to perform multi-stream traffic simulation over Ethernet layers. Install PacketCheck on 2 PCs and invoke PacketCheck on both the PCs by selecting appropriate network interface card. First, let's invoke PacketCheck in normal mode on the appropriate network interface card in the source PC. PacketCheck provides pre-configured files to perform Ethernet testing with different payload configurations. Load this file and verify all parameters on all the streams. The configuration file has 3 streams: BERT, impairment, and reports. Impairments allow you to test the router or switches under impaired conditions. In the Layer tab, enable TXRX, select Layer 2 as Ethernet, Layer 3 as IP, and Layer 4 as UDP. Set the source and destination MAC address, IP address, and UDP port numbers. In the BERT stream, select payload type as fixed bit error rate pattern and set the value as 44. Set the same parameters for impairment and report streams as well. The report stream is set to generate reports in the destination PC. No settings are required in the source PC. Impairments can be introduced to each stream while transmitting the traffic. Impairments can be activated only after starting the traffic. Here we are choosing to delete 4 bytes, this impairment will result in 4 bytes being deleted from every frame continuously. Now, let's invoke another instance of PacketCheck in normal mode on the appropriate network interface card in the destination PC. Similar to source PC, load the pre-configured file for all the streams. Observe the values in each tab. The MAC address, IP address, and UDP port numbers are swapped with respect to the settings in source PC. For the report stream, specify the periodicity of the report per stream. Also, select the path and enter the file name to save the reports in XML file format. This completes the configuration part. Now, let's start multi-stream traffic on both PacketCheck instances. Observe the sync status for all the 3 streams. Also, observe the data rate for throughput measure. Invoke Wireshark to verify the BERT pattern on the source PC. Start capturing the traffic on the selected interface card. Observe the user-defined fixed BERT pattern within the captured frames. Similarly, invoke the Wireshark on the destination PC and observe the same BERT pattern on each frame. Now, let's return to the source PC and perform the impairment action. Before we activate impairment, observe the frame length value in Wireshark. For example, here we see that typical frame length value is 1514. Now, let's activate impairment on the source PC and observe how the bytes are deleted from each frame. The frame length value is displayed as 1510 after the impairment instead of 1514. Now, let's go to the next stream, where the report generation has been enabled on the destination PC. Now, stop the traffic. Once the traffic is stopped, an XML file will be created in the specified directory. Open the XML file using Internet Explorer. Observe that reports are generated for every 4 seconds. Now, let's explore how PacketCheck is used for simulating real-time IP traffic such as video, HTTP, FTP, and so on over the network. For example, here, we already have a captured SIP video call in GL proprietary HDL file format. PacketCheck can transmit and receive such pre-captured traffic files. At runtime, HDL file is opened and the frames are read one by one. The protocol headers are modified according to the packet header configuration, but the payload is left intact. The resulting build packet is transmitted. Now, let's add a stream and rename the stream as HDL. Select the layer 2 as none. In the payload option, select the payload type as HDL. Browse and select the HDL file containing a video call. Invoke GL's Packet Scan software, an all-IP analyzer monitoring application. Within Packet Scan, invoke Packet Data Analysis View to analyze the captured traffic on the destination PC. Select the destination network interface card and start real-time capture. Now, return to PacketCheck and start the HDL stream. Observe the statistics in the PacketCheck on the destination PC. Observe traffic is being captured in packet scan simultaneously. Invoke Packet Data Analysis View and observe the complete video sessions. Now let's illustrate how we can perform round-trip delay measurements using PacketCheck. Invoke source PacketCheck in normal mode. Add a stream and name the stream as delay. On the source PacketCheck, in the Payload tab, select the PRBS pattern as QRSS. Configure Layer 3 and Layer 4 protocols as IP and UDP. Configure source and destination address for MAC and IP protocol. Enter source and destination UDP port number. In the Delay Measurement tab, select measurement type as round trip. Now, invoke PacketCheck on destination PC. This instance of PacketCheck must be started in loopback mode to loop back the received traffic back to the source without any modifications. Select Layer 3 and Layer 4 protocols as IP and UDP. Click Start on both instances of PacketCheck. Observe the sync status and the round-trip delay measurements. This completes the PacketCheck training video. Thank you.